Calculating the mean QRS axis is not always easy at first, but let's take the time to understand it. Then we'll show you a few tricks in order to get the axis right quickly. Basically, the mean QRS represents a summation vector. Imagine if all the individual depolarization vectors were summed up into one big vector. Figuring out the mean QRS vector is figuring out where that big vector is pointing to. In a normal person, it will be pointing towards the left ventricle because the left ventricle has more muscle mass than the right ventricle and therefore more electrical vectors. Remember the diagram we created when we assembled all the vectors of the limb leads? Here it is again. Now if we would add angles around the circle according to established convention, it would look like this. The mean QRS is said to be normal when it lies between -30 and +90 degrees. There is left axis deviation when the axis is between -30 and -90 degrees. There is right axis deviation when the axis is between +90 and 180 degrees. An axis which lies between -90 and 180 is considered to be an extreme axis. Here are two methods to properly calculate the axis. First, the tall R wave method. Identify the two leads in which the R waves are tallest and of equal height. The mean QRS axis will be directed between both. For example, in this EKG, we circle the two tallest R waves which are of equal height. The mean QRS axis will be therefore directed somewhere between both leads. Second, the isoelectric method. Identify a lead in which the QRS is precisely isoelectric. The mean QRS axis will be pointed perpendicularly to that lead. Sounds complicated, but let's go back on this EKG. Finally, there are also a few tricks to quickly identify the direction of the mean axis. In order to do this, simply look at the mean amplitude of the QRS complexes of leads 1 and 2. If lead 1 is positive and lead 2 is positive, the axis is likely to be normal. If lead 1 is positive but lead 2 is negative, there is left axis deviation. If lead 1 is negative yet lead 2 is positive, there is right axis deviation.